Everybody knows the feeling. You have a speaker coming to your school, your talent show's coming up, you go to turn on the soundboard, and it's not working the way you want it to. By the end of this episode, you'll not only be able to troubleshoot your own soundboard, but you'll be able to walk into any auditorium and know what to look for. This is E-ducation. Let's get started. Now, before we get rolling, I just wanted to give a quick shout out to my friends over at Parsons Audio. I've moved totally digital with all of my mixing boards, so none of them actually have buttons on them. Parsons was nice enough to lend me this analog Yamaha board so that you can actually see all the concepts we're talking about and not just have me rattle them off to you with no real visual. I'll put a link to their website in the description. If you're somebody who likes to test stuff out before you buy it, definitely give them a call because they are huge on that. With that being said, let's get started. This video is going to be divided into the following. We're going to start with some need-to-know vocabulary. Then we're going to break down the major categories that you'll find on the soundboard and what they do. Then we're actually going to walk through each of these functions top to bottom. Then we're going to go over some of the specialized functions you'll find on a board like this one. All right, vocabulary, here we go. Here are the major categories of things that you are going to find on the board. First off, you are going to have hardware inputs. Hardware inputs are where signals from outside the board can enter the board. These XLR inputs up here we would call hardware inputs. These line inputs we would call hardware inputs. Even these return tracks are places where sound can come into the board. Next, we are going to have hardware outputs. That is where signals from the board can leave to go to other equipment. These are things like your main outputs, anything that says send, your headphone jack, anything that says out on it is most likely going to be a hardware output. The next category is signal processing. Signal processing is anything that is going to adjust the tonal characteristics or the dynamic characteristics of one isolated signal. This can be equalizers, reverbs, anything like that. They are all going to be lumped into signal processing. The next category that we're going to find on this board a lot is something called routing. Routing is anything that's designed to take the signal and send it to a different component on the board. Anytime you see something that says aux or auxiliary, AUX, that is a routing component. Lastly, we have things that are related to the main output. We can call this our master stage. This includes the volume faders. If your mixer has digital effects built in, lots of times those, which are technically signal processing, are within the master stage, or once again, the main output stage. Awesome, let's start poking stuff. All right, the first thing we want to look at is the fact that we have numbers on the board. And if we look, those numbers vertically align with each other. Each one of these numbers corresponds to what we call a channel strip. So suddenly, this whole sea of knobs that we have is actually just the same, 8 knobs repeated over and over again. One of the best analogies I've heard with boards and audio in general is just think of it like plumbing. Signal comes in, and then it has to leave somewhere. If you were to pour water in this input, it would flow down the channel strip into this pool where all of the other channel strips also dispense. With that in mind, we are just going to look at this first channel strip. That being said, we can ignore everything from channel 2 over. Awesome. We're going to start at the top of this first channel strip with our hardware inputs. First off, we have an XLR input, which I'm running this mic into right now. And then we also have a line input. Microphones tend to need more gain. They need more assistance than line level inputs. So don't plug anything into your mic input that could be coming from a line level signal. Be weary if you have to use a 1/4-inch adapter to an XLR adapter to get something into the board. You could potentially damage the preamps. So if it's a 1/4-inch, always test the line input first to see if you get enough juice out of it. Most instruments don't run at line level, so you can use a DI box or something like that. But if you're plugging anything box shaped into the board, I would use the line level input. We are going to ignore this insert jack until a little bit later. I know it says insert, so you'd think you plug stuff into it, but it's actually a specialized jack that we're going to talk about later on in the video. Now, if you're using a condenser mic, you're going to need something called phantom power. So phantom power is always going to be labeled as plus 48, sometimes plus 24 if it's an older board, or it's going to say phantom. So if we look right over here, there is a button that says plus 48. I'm not going to turn it on because this mic doesn't need phantom power. But if you're using hanging mics, if you're using boundary mics, even some guitar preamps and stuff use phantom power. So check to see if you need it. If you do need it, that is the button. And again, the phantom power corresponds with the microphone inputs, the XLR inputs. Moving down this channel strip, we do have something that is technically signal processing, but can really be considered part of the inputs, and that is your gain knob. People often confuse gain and volume. The gain knob is just so that you can get a usable signal with the rest of the channel strip. What I would suggest doing with the gain is turning it up until you see this peak, button blink, and then turn it down a bit. If you turn the gain up too high, you'll see this peak light turn on and your sound will get distorted. No matter what you do throughout the rest of the channel strip, you won't be able to clean that up. Again, that distortion happens on the way in. So if your sound is distorted, especially when you turn the volume fader down, it means that your gain is too high, so then you can dial it back. Lots of times mixers will also have this button with the little, it almost looks like it says square root of 80. That is a high pass or a low cut filter. What that does is it takes some of the really boomy low end of the microphone out. So if I turn that off and then say beach day, you should hear a very pronounced low end. Now if I turn that on, beach day, there's not as much, we call those plosives, there's not as much low end. Lots of times pressing that can help clean up some feedback, especially if your microphone gets bumped and you hear that low rattle through the speakers of the microphone vibrating. Now moving down, not all boards have these, and in fact I have it turned off right now on this board. This is a compressor. So to quickly say what a compressor does, in case your board has one, what it does is it lowers the loudest parts of the signal so that you can raise the entire volume. I don't know if you can see this graphic, but it has a straight line and then it actually shows it sort of turning into a little angle. Again, all this does is it keeps the loud parts in check so that you can boost the volume. This board groups the compressor with the sort of signal processing of the input. It really is just a signal processing function. Now we move into the real meat of the signal processing, which is the equalizer or the EQ. On this board, the knobs are green. Generally, the EQ knobs will all be the same color. Now, on this board, we have 3 high, mid, and low. Some boards will have high, mid, and low. Some boards will have high, mid, low, but then another knob in the middle that lets you change where that mid knob focuses in the frequency spectrum. Whatever your board has, the goal of these is to change the tone of the actual signal. So in this case, if I turn up the high, it gets really, really crispy, almost too much. The S's get really pronounced. But if I turn that all the way down, it gets super muffled and there's not as much definition in the sound, not as much clarity. With the mid-range knob, if I turn it up, it gets really kind of honky, which is quite unpleasant. I may even be peaking, so I'm going to try to talk quietly. It's a very blunt sound. It gets kind of boxy. If you turn the mids all the way down, we call this a scooped sound. It gets very thin. There isn't that much aggression in the mid-range. It's not punchy, but it doesn't really have any fullness to it. Now the low end, and I'm actually going to turn off the low cut for this. If you boost the low end, it gets really, really muffled. And this might be peaking as well. Nope, not quite. So it gets really, really muffled. It's going to be more prone to a lot of types of feedback. If you turn the low all the way off, it does start to thin out. Now, the vocal range doesn't actually use that much low frequency. Sort of where the low knob starts coming in is right at the bottom of like a male speaking range. So be careful with it, but you aren't actually going to need to adjust that knob too much when it just comes to speaking voices. If somebody has really bad mic technique and they're just blowing like B's and P's into the microphone, you might, if you don't have a low cut like I have, you might just want to turn down that low knob. Their voice will lose some of that, radio sound, that boominess, but it will help with those, again, we call those plosives. So in the case of this board, that is the signal processing part of the channel strip. All right, now we are going to move down the channel strip to some routing components. These are usually labeled as aux. If it says monitor, MON, FX as well is generally a routing component. In the case of this board, we have two knobs. We have aux1 and aux2. Aside from the main mix, we have two different locations that we can send this mic signal. We can call these submixes, we can call them buses, we can call them different sends. The important thing though is if we look, we have aux1 and aux2. Up here at the top, we also have aux1 and aux2. And we can see down here that these are sends, which means that these are hardware outputs. They're going to be leaving the board. These are great for if you are doing a concert or something where you need monitors and you want people to have different monitor mixes. As an example, say that this is my vocal track and I want to send it to the drummer and the drummer is on aux1. I can send as much lead vocal to the drummer as I want. To demonstrate this, I'm actually going to take the recorder out of the main outputs of the board. I'm going to plug, this is the left channel, into aux1, so the gray is left, and then I'm going to plug this red cable, which is the right side, into aux2. So then what I should be able to do is turn up those aux channels, and if you hear it on the left side, I'll be turning up aux1, and when I turn up aux2, you should hear it on the right side. Let's see if that works. All right, so I am turning up, is that working? Ooh, yes it is. I'm turning up aux1. Now, looking on this board, there is also a sort of main auxiliary level control. So make sure that your aux send, make sure we can see that, is up as well. If you're not hearing anything, just look for a knob that says like aux volume, aux send, something like that. And aux2, now we're balancing it out in the middle because I have both channels. If I turn aux1 off, you can see it's on the right because I plugged my right channel into aux2. So say that this channel that you're hearing right now is the drummer's monitor and I wanted to add more vocal. This isn't going to affect the main speakers. So plug your monitors into the aux sends. Sometimes it says monitor just for labeling. Let me turn aux2 back up. There we go, or aux1. Sometimes it will say monitor just for labeling or FX, but this is an example of routing where rather than going through the main outputs, I'm using the auxiliary outputs and using these auxiliary knobs, these routing knobs, to send it where I want it to go other than just the main output. Again, I did have to use this sort of master knob, this like overall auxiliary send knob. But again, think plumbing, think water. We're basically putting in some sort of water splitter with this knob saying, okay, we're going to send water somewhere else and it's going to go through. And then this is sort of the master spigot, if you want to call it that, that sends it to the auxiliary jack. All right, I just plugged them back into the mains, so we should be back to our original level. Now, the one other button on this auxiliary strip is this pre button. Now, that pre button tells us whether or not it's going to take that signal from before or after this fader. So if you do a mix down here, say I like move all these things and it's like, wow, crazy, our mix is so good. And then I move all of these aux dials to the same place. If I had a whole band, I could show you, but unfortunately it's just me. If I had all of these aux dials at the same level, it would sound like this mix. Because again, all of our faders are moved and none of these pre-buttons are pushed down. However, if I pushed all of those down, what it would do is split off this signal before it reaches any of this sort of balancing stuff. This is related to our main out, our mastering stage. It would take the signal before that, so it's not going to sound like this mix. It would sound like they were all turned up to the same level because that's what I have here. So you can adjust your mix this way and not worry about what is going to the main speakers. So again, if you're using monitors, you're probably going to want to turn on pre for that monitor mix. That way, if you adjust something on the monitor, you don't then have to think about, oh, well, if I turn it up in the mix, is it going to affect the monitor? If something's too quiet coming out of the main speakers, you don't have to worry about messing up the monitor mix. You can keep them separate. This is also great if you run a church band or something and you live stream, because if you have the congregation in-house and you have, say, a drummer in there, you're not going to need to put a lot of the drums through the speakers. But if you're live streaming, you need to mic up all the drums and you need to make them stronger because the people aren't in the room hearing the acoustic drums. So what you can do is get your main house mix set up and then run an aux send to your live stream where you can do a mix that's totally just for the live stream apart from the main house mix. We are going to get into some other routing stuff once we leave the channel strip, but for right now, we start to move down into our master stage, our main output stage. And that starts with pan. So many people already know what this is. It stands for panorama. The idea is you can move a sound between the left and the right channels so that you can have it totally in one speaker, totally in the other speaker, somewhere in the middle, 45 degrees. And really all this is doing is adjusting how much signal is being sent to each side. It's really just tricking our brains. So if you put an even level on the left and right, it sounds like it's right in the middle of your head or like right in the middle of the speakers, when in reality, it's just that there are identical things coming out of both sides. To demonstrate, we're going to jump back to the recorder here, and I'm going to turn the pan knob from left to right, and you're going to hear it go from one speaker to the other. All right. To the left. We are turning the pan knob to the left. I can hear it in my headphones, so hopefully you can hear it in yours. And now I'm turning the pan knob to the right. We are in the center. Now we are moving to the right. Yay. Cool. Now just understand, if it's a stereo input source, so there's a left and a right channel already, on this board, 5, 6, 7, 8, 9, 10, 11, and 12, these 4 channel strips that have 2 numbers, those are technically either mono or stereo channel strips, depending on what you plug in. With that in mind, the pan knob actually becomes balance. So if you plug in a stereo track and you turn the pan knob, it doesn't actually consolidate it. It just sort of cuts off that other side. So if you're listening to a song that has like acoustic guitar on the left and, electric guitar on the right, all you'll do is just cut out one of the instruments because it's not actually moving it per se. It's not working with 2 of the same signal. You're just telling it which side is going to be louder. Because of that, if you're only getting one side of your music, check to make sure you're using a stereo cable, then also check your pan. That could be the issue. Moving down the board, this particular board has on buttons. So if I press off, and suddenly I come back. Great. Not all boards have that. I actually don't tend to use boards that have these, but I guess they're useful. You get to know what tracks you're actually working with. Now, a thing to note is if you turn this off, it turns off your entire channel strip. So if you have something running through an auxiliary send, it's going to stop working. So moving down from the on-off button, we reach this button that says PFL. Now that stands for pre-fader listen. What that does is if I click it, you'll see that suddenly we have lights happening on this meter. This is here so that you can, A, get a visual of what the level is of your track, but B, it sends that track to the headphones so that even if your fader is off, you can still hear it. So to demonstrate that, I'm going to take these cables out of the master output of the board and plug them into the phones so that you can hear the microphone come in and come out. The PFL button is on. We're plugged into the headphone. PFL button is on. PFL button is off. To turn it back on. Now it is going to. Lovely. This is awesome if you're hearing something weird in your sound setup and you know what mic it is. You can actually click through and listen to each individual source even while the main mix, the main outputs are playing everything. It's also great because you can turn off your main mix so that nothing is coming through the house speakers, and you can sound check different mics without actually having to put things through the mains. This is called a line check sometimes, where they're not actually hearing it through the speakers. They just want to make sure everything works. And again, that falls into the routing category because we are moving the signal from the channel strip somewhere else. All right, now we move down to these two buttons here. Now, when I first started working with boards, all the extra little buttons places just confused the heck out of me. These buttons are also routing. Luckily, they've done a really good job with labeling everything. So we're going to take a look at what these do. If we look, we have a little red button that says ST. And if we look at our main fader here, our stereo out fader, it is also red. And stereo starts with ST. Crazy. Now, again, I got this board literally just to make this video, so I had to just click through and make sure that I actually remembered how everything worked. My guess was that this would take things in and out of the stereo mix. So let's try that. My mic is currently working. And so I'm going to click this and see it did cut out. Good. And that is because this button means, are we sending this signal to the stereo out? Again, it's color-coded ST. Stereo starts with ST. Now, there is the one above it, which I'm going to lift this so you can see it. It says 1-2. And we also, over here, have a fader that says group 1-2. So I would guess that if I click that, the sound goes to group 1-2. It's basically just saying that it's a stereo channel. It has left and a right. Now, to test this, I'm going to do the following. I'm going to take the mic out of the stereo output, which is what we're listening to. As you can see, I'm plugged into stereo out. Let me move these so you can see that. I bet if I take this mic out of stereo output, or out of the stereo routing there, but I put it into group 1-2 and then send the group 1-2 to the stereo out, I should still get sound, because instead of sending this directly to the output, I'm going to send it to here and then to the output. So right now this is not doing anything because it's not being used. But if I turn this off, now I get my mic. Great. And also this fader now works because I'm sending it, instead of directly to the stereo output, I'm sending it to the 1-2, or we can just call this group 1. I'm sending it to this group, and then we see another stereo button there, stereo output. Then I'm sending it to the stereo out. So lots of times you'll see, I remember I was using a board that had like 1, 2, 3, 4, 5, 6, 7, 8, and I was just like, what? But all you need to know is that this is telling you where the signal is actually being sent after this fader. So just for cleanliness, I'm going to send us back directly to the stereo output. So this fader is the volume in relation to the rest of the signals. So this is not gain. If your signal's distorting, that's this guy up here. But once all of this is set, once you've gone through the rest of your channel strip, this is how you're going to balance it with the rest of the stuff. Think of it like a shower. If channel 1 is hot water and channel 2 is cold water, this is where you adjust the water pressure in the pipes, the gain knob. These are where you actually say how much of that temperature you are going to let into the stream of water that is hopefully not scalding your skin. So one last thing I want to say about these groups. This is great if you have a whole bunch of like instruments. So say you're using a board with, 32 inputs. If drums take up 9 or 10 inputs, you have, mics on every drum, things like that. You can just send them all to a group. We call these submixes or buses, and then turn your entire drum mix up or down without affecting everything else. And it makes it so you don't have to pull down 9 or 10 faders. you're just sending them to this little pool before they go to the stereo out. Great, so we've made it down to the bottom of our channel strip, but we still have some other things happening here. So we still need to look at a few hardware outputs, and we do need to look at just some of these other knobs. Luckily, these are all just routing. Now, we're going to go back up to this jack right here, the insert jack that I alluded to earlier in the video. The idea behind the insert jack is it actually lets you plug things in between the gain knob and the rest of the channel strip. That's really cool because if your board doesn't have a compressor on it like this board does, you could buy a hardware compressor and actually put it right where this compressor is on this board already. If I had an entire external channel strip that had its own compressor, noise gate, EQ, de-esser, things like that, I can actually put it right after the gain and include it in this channel strip. Now, in order to use the insert jack, you need what's called an insert cable. An insert cable is a TRS, or what we can call a balanced quarter-inch cable or a stereo cable. On the other end, however, it splits into 2 quarter-inch mono or just TS cables. Instead of acting like sort of a, normal one-directional cable, the insert jack uses the tip connection to send the signal and the ring connection to return or to receive signal. So if you wanted to plug something into this channel strip, you would take the stereo, TRS, whatever you want to call it, end of your insert cable, plug it into the insert jack, then you would take the end that corresponds with the tip, usually it's either gray, it's usually labeled tip if it's an insert cable, plug that into the input of your external gear, and then plug the red cable, which is usually labeled ring, into the output of your gear. That way, the board sends the signal to the input of the other equipment, and then the other equipment sends the output signal back into the board. Now, a way that I've practically used this is if I'm running sound for an a cappella event of some sort, and I need to drop the bass an octave or just add an octave below it, I will actually run an insert cable out of the insert jack and plug it into a guitar processor that has an octave drop on it. That way I can just take that one mic and apply the effect to it and not have to worry about applying that effect to like everything else on the board. And when I want to shut it off, I can either unplug the insert jack or just turn off the guitar pedal and it'll work fine. So as I mentioned earlier, you have your auxiliary sends, aux1, aux2. Again, these are basically the same as your stereo output, but just controlling these jacks instead. So you do your entire auxiliary mix, and then this is how loud that entire mix is as a whole coming out of this send jack. Now, if we look, it says aux send, aux send. So again, everything's labeled. So then we have our aux return, which is actually both of these, which means you can have a stereo return. Again, we have our phantom power button to turn on phantom power in those XLR ports. So then we have this dial that says monitor/phones, and we have a button that says group, or if it's lifted up, stereo. And for the monitor output, what that is saying is, where is it going to pull its signal from? So either if you press it down, it's going to take this group 1-2 signal and send it straight to the monitor. So this would affect the actual signal, whether or not you're sending it through this one as well. If we lift that up, it's going to take the signal from the stereo output. And then the 2-track in. So if we see the 2-track, that is what we call our RCA or, coaxial or composite jacks. The 2-track in is going to be different from these RCA cables that are on these channel strips because this one just goes straight to this knob, which then either sends it to the stereo output or sends it to the monitors. This is awesome if you are sending out these 2 composite jacks, you're sending audio to some sort of external recorder. The 2-track in is where you can then monitor that to make sure that your recorder isn't clipping. Great, now that we've taken a look at this board, I actually want to jump over to the interface that my digital board uses so that you can see that all of these concepts really apply to most soundboards, whether they're analog or digital. So right now we are actually looking at the interface of the digital mixer that I'm using to record the audio directly into the camera. So as you can see, it kind of looks like a normal board. We have the volume faders down here, and we also have numbers that correspond to channel strips for each microphone input. Now, we do have some tabs up here on the top, but we should be able to identify all of these things into one of our major categories. Now, because this is just the interface to communicate with the mixer, all of the hardware inputs and outputs are going to be on the physical board itself. That being said, we only need to worry about signal processing, routing, and then our main output stage. So if we click up here on channel, and then go over to the one that my mic is on, we can see that we have our entire channel strip laid out, and let's try to identify some of these things. We have our preamp gain right here. It says gain, mic gain. Then we have our phantom power switch. Up here we see 48 volts. It also says phantom. On this board, we do have a few options for signal processing. Each channel in this board has a noise gate, an equalizer, and a compressor. You don't need to turn these on to get the board to work, but they're just more signal processing. Then sliding over, we have our routing. So we have a bunch of different auxiliary tracks on this board. It also has some auxiliary tracks, auxiliary buses in here dedicated just to effects. Lastly, over on this little tab, we have our main output stage. So we can see things like panorama. This is our on-off switch right here. This board has other features. Again, it has some more advanced features since it is digital, but really this is just an extension of the category we've already looked at. If we go up to these other tabs on top, all we're doing is going into each of those sections of the channel strip. We can see here that we even have an insert. This time it's not a jack since it's totally digital, but it functions the same way. We move through our signal processing with the fine controls for each of those gate, EQ, and compression. Then we have an entire tab just for our auxiliary sends. Instead of that pre-fader button, we actually have a whole list of different options we can choose. Same thing applies over here for the effects channels. Then we can actually go up and we have our master or our main output stage as its own dedicated tab as well. Now, most of these were available in the full channel strip view, but it is nice to just have them laid out without all the clutter. We have the effects tab, which is just more signal processing. As you can see, I'm using a couple different compressors for different channels here. Those are being handled as inserts, so just like that insert jack on the top of the board that we saw right underneath the line level input. And then this last one, this meter tab, just shows you the status of all of your signal levels. If something is peaking, you can just look at this analog inputs line and see which one is maxing out so that you can easily identify it and go back and fix it. And since this is a digital board, if I come over here, we actually have a very sort of in-depth, we call this a routing matrix. The board will already be set up to go most of the time when you get it, so this isn't really something that you need to mess with too much. But again, it just falls into that major routing category. So even with this board, yes, there's a lot of buttons. Yes, there's a lot of stuff on the screen all moving around and blinking. You could click on anything on here, but when it comes down to it, it really still falls into one of those 4 categories, or 5 categories. So think about what you need to accomplish. Think about the problem that you're running into. Think about what you are trying to make happen. And just think about which of those major categories you need to look for. If you're confused about what something does, again, just think about how it might fall into one of those major sections. All right, so that is pretty much it. We went through a lot. I hope some of that stuck with you. I will be uploading a guide as well that sort of reminds you of the individual stages of this board. The most important thing, though, is that pretty much everything on the board is labeled. Just focus on that one channel strip, and then everything else is just sending that signal other places. Let me know if you have any questions on this. I would be happy to answer them. Thank you for stopping by, and I will see you next time.